To talk about another measure of variability. Just like we talked about the range yesterday, we're going to be learning about other measures of variability. So let's go ahead and define what does it mean to be a measure of variability. It says a measure of variability is a way of describing how spread out the data is. That's the first blank. How spread out the data is. How far away are the data points, the lowest one and the highest one, from each other. It is also described as how much the data deviates from the center. The center being measurements of center such as the mean. So for example, when I put a grade for you guys in the grade book, I get what's called a class average. So I can assign, let's say, a classwork grade. And all my yellow math students, the class average might be an 87. And let's say that you got a 75 and the class average was an 87. That would be something that you could say, what am I doing that's different from the average other groups of my students? How can I get closer to the average score of kids in my group? Okay, so today we're going to talk about something called the interquartile range. Okay, what do you think inter means? Middle or between. What does quad mean? Four. So the interquartile range is a measure of variability that splits the data into four equal-sized or congruent equal-sized quartiles. It represents the middle 50% of the data. So it's going to say, here's where 50% of the data lies between. Now I'll tell you that we already know how to find the second quartile, because when we find quartiles, we're finding median. Okay? But before we get into how we're going to find the interquartile, I want you to take a second and I want you somewhere on your page to define another measure of variability. I want us to define an outlier. Okay? An outlier is a measure of spread or variability. A measure of spread or variability. And what it is it's a data point. You're defining this anywhere on your paper or on the next blank page, whatever you want. A data point that is significantly greater than or less than the majority of the data. And we're going to look at a data set below, which represents different costs of a camera at electronic stores. Looking at that data, can you identify an outlier? I would say 108 is much more of an outlier than 28, because the next highest cost from 108 is 71. So that's over a 30-point difference from that highest price to the second highest price, right? We're going from the lowest price to the next lowest price is only $8. So here's how we're going to find the quartiles. Step 1, we need to order the numbers from least to greatest. Do that now with the data set below. All right, so you should have ordered them from least to greatest: 28, 36, 44, 59, 66, 71, 108. Did everyone get that?
Yep.
All right, step 2, we need to find the median. Remember, when we find the median of a data set, I suggest crossing off the lowest number, then the highest. Second lowest, second highest, next lowest, next highest. This example has one median. It has a number that's directly in the middle. It is possible, like we saw yesterday, to have two numbers split center, right? How do we find the median if there are two numbers that split center? Priya? Find the mean or the average of those two numbers. Now here's why that's important. Because we found the median, that's answer D, 59. What's the minimum? 28, and the maximum?
108.
108, okay? Now here's where things get a little tricky. This median is considered to be the second quartile. Quartile 2, okay? We now need to group our numbers in our first and our third quartile. Now because 59 is a data point and it's exactly in the middle, we are not going to group it for when we find the median of the lower and the upper quartiles. If, like yesterday, two numbers split center, the lower number would be included in the first quartile and the higher number would be included in the third quartile. But because 59 is perfectly in the middle, it's not included in either of the quartiles. Now, step 3 is finding the median of the lower and upper quartiles. So the lower quartiles are located right down here. So cross out 28, then 44. What's the first quartile, or what's the median of the first half of data?
36.
36. And what about the third quartile?
71.
71. The interquartile range is what you get when you subtract the quartile 3 and quartile 1. Do that now. What is the interquartile range? Say it to me.
35.
Everyone get 35?
Yes.
35. It's what you get when you find 71 minus 36. Okay? Awesome job.